Assalamualaikum and Hi. My name is Nana AMANI binti KAMAL. My student ID is 2023838236 and I am from CDCS 14328.
My name is DINIE UMAIRAH binti KAMARUZZAMAN. My student ID is 2023667134 and I am from CDCS 143.
My name is AMANINA binti HIDZER. My student ID is 2023852748 and I am from CDCS 14328.
I am SITI NAJIHAH binti AZIZ, the last candidate for this group. Student ID 2023828612 from class CDCS 14328.
What is differentiation? Differentiation can be defined as a derivative of a function with respect to an independent variable. Differentiation in calculus can be applied to measure the function per unit change in the independent variable. There is 5 things in apply of differentiation. First is related rate. Second is analysis of function 1. Third is analysis of function 2. Next is a rho theorem and mean value theorem. And last, applied maximum and minimum problem. And we choose applied maximum and minimum problem to solve.
So what is applied maximum and minimum? Applied maximum and minimum is about finding the highest or lowest values or things like numbers, function, or quantities. The process of finding maximum or minimum values is called optimization. We are trying to do things like maximize the profit in a company or minimize the cost or finding the least amount of material to make a particular object.
Why we use maximum and minimum? We use this method to solve optimization problems such as maximum profit, minimizing the amount of material used in manufacturing an aluminum can, or finding the maximum height a rocket can reach.
We move to our first problem statement, which is a rectangular garden of 375 m square will be fenced. The fence price of the long sides are 3 ringgit per meter, while the broad sides are 5 ringgit per meter. Let's X represent the long sides of the garden and Y represent the broad sides of the garden.
Problem solving. A. Show that the cost C of the material is given by C equal to 2,250 over Y plus 10 multiply Y. Firstly, cost, which is C, equal to Rm 3 ringgit in bracket 2x plus 5 ringgit in bracket 2y. It will become 2x plus 10y. Given rectangle garden is 375 meters square, it will become x, y equal to 375. Substitute it, so x equal to 375 over y. So the conclusion is cost equal to 6 in bracket 375 over y plus 10y. It will become 2,215 over y plus 10y, and it will show the answer.
So for question B, the question asks us to find the value of x and y that will minimize the cost of the material. So we make the equation C equals to 2250 to the power of negative 1 plus 10y. So dc over dy equals to negative 2250 to the power of negative 2 plus 10 equals to negative 2250 over y squared plus 10. So we let dc over dy equals to 0. So negative 2250 over y squared plus 10 equals to 0. 10 equals to 2250 over y squared. So 10y squared equals to 2250 and y squared equals to 225. And the final answer for y is y equals to 15. Next, we use second derivative test. D squared c over dy squared equals to 4500 y negative cube equals to 4500 over y squared. So when y equals to 15, d2c over dy squared equals to 4500 over 15 cube equals to 4 over 3, which is more than 0. So y equals to 15 is a minimum value. When y equals to 15, x equal to 375 over 15. So x is 25. C, hence, find the minimum cost of the rectangular garden. So minimum cost, C, equals to 2250 over 15 plus 10 times 15 equals to Ringgit Malaysia 300.
Problem statement 2. A closed cylinder full tank of radius x cm and height y cm has a surface area of 200 pi meter square. Problem solving for question A, which is express y in terms of x. We must use cylinder surface area, which is 2 multiply pi multiply radius square plus 2 multiply pi multiply radius multiply height equal to 200 pi. In this question, we must replace the radius and height, which is 2 multiply pi multiply x square plus 2 multiply 5 multiply x multiply y equal to 200 pi. And then we substitute the 2 pi, it will be 2x squared plus x multiply y equal to 200 pi over 2 pi. And then we simplify the right side, it will become x squared plus x multiply y equal to 100. And then x multiply y equal to 100 minus x squared. And then for the final answer is y equal to 100 minus x squared over x.
The question B asks us to find the volume of the cylinder. To answer this question, we need to find first what is formula volume of the cylinder, which is pi r square h. And then we just substitute the h with y, which is y is 100 minus x square over x. And then the volume that we get is 100 pi x square minus pi x power of 4 divided by x. And then the final answer for volume of the cylinder is we get 100 pi x minus pi x.
For question C, hence find value of x such that the volume of the cylinder is maximum. V equal to 100 pi x minus pi x cube. First, find dV over dx. dV over dx equal to 100 pi minus 3 pi x square. Second, find x where dV over dx equal to 0. 0 equal to 100 pi minus 3 pi x square. 0 equal to 100 minus 3x square. X square equal to negative 100 per negative 3. So x equal to square root 100 per 3 equal to 10 over the square root 3. So we can get x equal to 5.774 cm. Okay, next find second derivative d2v over dx2. dv over dx equal to 100 pi minus 3 pi x square. d2v over dx2 equal to negative 6 pi x. Let x equal to 10 over square root 3. d2v over dx2 equal to negative 6 pi times 10 over square root 3. So we can get negative 108.828. So less than 0. That is maximum point. We find value of the cylinder. V equal to 100 pi x minus pi x cube. So V equal to 100 pi times 10 over square root 3 minus pi times 10 over square root 3 cube. So V equal to 1209.200 centimeter cube. So we can conclude maximum volume of the cylinder with the surface area of 200 pi meter square is 1209.20 centimeters cube with radius x equal to 5.774.
In summary, the application of differentiation to determine the maximum and minimum values is a flexible and important tool that can be used in this topic. Hence, identifying and using formula for both the first and the second derivatives is important to determining whether a function reaches a maximum or minimum value. Lastly, these mathematical methods are important to improve understanding and optimize the effectiveness and efficiency of solution.